Out here, deep into the solar system and far, far away from the warmth of the sun, you would expect everything to be frozen, dark, and completely lifeless. Frozen solid for billions of years, and yet we have images like this, captured by one of NASA's most advanced research probes. It shows us bizarre, chaotic structures, a world painted in vibrant yellows, reds, and greens, a world being torn apart by a hidden, violent force. This is Io, Jupiter's third largest moon, and it is more alive, more geologically active than any other body in our entire solar system. Its rocky surface is caught in a constant, raging battle between fire and ice, and today we are going to dive deep into the heart of this chaos to understand the forces that are literally stretching this world to its breaking point. The king of our solar system, Jupiter, has a family of nearly 100 officially recognized moons, a number that keeps growing. But most of those are just tiny rocks. There are 4, however, that are exceptionally large. We call them the Galilean moons, named after the astronomer Galileo, who spotted them with one of the very first telescopes ever made back in the 16th century. The outer 2, Callisto and Ganymede, are massive worlds of ice and rock. Their surfaces are ancient, dead, and heavily cratered. Next is Europa. Europa is covered in a smooth, thin sheet of ice, and beneath that ice is a vast, global ocean of liquid water. It's one of the most promising places in the solar system to look for extraterrestrial life. And then there is Io, the closest of them all. It orbits just 350,000 kilometers above Jupiter's cloud, tops about the same distance as Earth is from our own moon. It's roughly the same size as our moon, too, just a little bit heavier. In fact, Io is the densest moon in the solar system. Why? Because it's made almost entirely of rock and metal, while its siblings are made of ice and rock. The difference is so extreme that Io is believed to have the lowest water content of any known body in the solar system. It's drier than Mercury, the closest planet to the sun. It is a rocky world in a frozen part of space, and that is where the mystery begins. What makes Io special isn't just its composition, it's the action. This is the only place outside of Earth where we know volcanoes are erupting on a regular basis. Io is the most volcanically active place in the entire solar system, with up to 400 active volcanoes dotting its surface. We first discovered this back in 1979, when the Voyager 1 probe flew past, even from 20,000 kilometers away. With cameras we'd consider primitive today, it saw 9 distinct volcanic eruptions blasting material into space. But here's the paradox. Outside of these volcanic zones, the surface temperature drops to minus 130 degrees Celsius. The sun is too far away to provide any warmth. So where is all this heat coming from? How can a world so far from the sun be so violently hot? The answer is gravity. Io is caught in a very dangerous neighborhood. It's close enough to Jupiter to avoid being torn apart, but not close enough to be safe. Jupiter's immense gravity pulls on the moon, stretching its very shape, and then, on the other side, you have the other 3 massive Galilean moons, Europa, Ganymede, and Callisto. They pull Io in the opposite direction, disrupting its orbit. This forces Io into an oval-shaped orbit, not a circle. So every 2 days, it swings extremely close to Jupiter, feeling its maximum gravitational pull, and then swings farther away, where the pull relaxes. It is constantly being stretched and released. Stretched and released. This is what we call tidal flexing. You know how our moon pulls on Earth's oceans, creating tides? On Earth, that pull lifts the ocean by about half a meter. On Io, Jupiter's gravity lifts the solid rock of the surface by up to 100 meters. Imagine the ground beneath your feet rising and falling by the height of a skyscraper every single day. This constant stretching and squeezing acts like a pump, generating insane amounts of friction and heat deep within the moon's core. That heat is the engine that powers the 400 volcanoes. It is a world powered not by the sun, but by the relentless, violent tug-of-war of gravity. But these volcanoes are nothing like what we have on Earth. On Earth, volcanoes form where tectonic plates collide, forcing magma up through a central vent, creating those classic cone-shaped mountains. Io doesn't have plate tectonics. The lava just bursts out from massive cracks in the crust, created by all that stretching. The initial explosion can throw lava dozens of kilometers above the surface, and above that, a plume of sulfur gas can rise for hundreds of kilometers. Sulfur is key to understanding Io's look. This sulfur surrounds the moon in a thin atmosphere. When it settles back down, it freezes and paints the surface. The yellow regions are frozen sulfur snow. The white and blue patches are frozen sulfur dioxide in the cold shadows. The green areas are created when sulfur interacts with Jupiter's intense radiation belt. And the red areas, those are the recent hotspots where the sulfur is still bubbling hot from a fresh eruption. And instead of building mountains, the lava tends to do the opposite. After an eruption, the ground often collapses, and molten rock fills the void, creating massive lava lakes. The biggest one is called Loki Patera. It's 200 kilometers wide. In the center, there's an island of solidified rock surrounded by a churning, active lake of liquid magma. It is a vision of hell happening in the frozen void of space. But if volcanoes don't build mountains on Io, then what in the world is that? This is Steeple Mountain. It rises between 5 and 7 kilometers high. It looks like a church steeple or something out of a fantasy movie. It's one of the most iconic images from Io, captured recently by NASA's Juno spacecraft. Juno arrived at Jupiter in 2016, and after its main mission, it was retasked to study the big moons. It did do close flybys of Io in late 2023 and early 2024, coming within 1,500 kilometers of the surface, and it revealed that Steeple Mountain is not alone. There are dozens of these isolated, jagged peaks all over Io. The talus is 18 kilometers high, more than twice the height of Mount Everest. They don't form in ranges, they stand alone. They look like they burst from the ground suddenly, and scientists believe they are directly linked to the volcanic process. Remember those collapsing lava lakes? The theory is that when a section of the crust collapses downwards, it creates so much pressure that it pushes a neighboring block of crust upwards. It's like if a sinkhole opened in your backyard and a new mountain instantly appeared right next to it. For billions of years, Io's surface has been in a constant state of violent collapse and uplift, creating this unique, otherworldly landscape. Sadly, these incredible images from Juno might be the last close-ups we get of Io for a very long time. Juno is running out of fuel. 2 new probes are heading to Jupiter, ESA's JUICE and NASA's Europa Clipper. But their mission is to study the other moons, Ganymede, Callisto, and especially Europa, with its hidden ocean that could harbor alien life. Io is the odd one out. No probe is heading back there soon, simply because it doesn't have an ocean and it doesn't have aliens, but that doesn't mean we've forgotten it. The science from Juno has reshaped our understanding of what's possible in our solar system. Priorities change, new rockets are being built, and someday, hopefully not too far in the future, we'll go back. Until then, we'll always have Steeple Mountain, a silent, impossible spire on a world of fire and ice, a testament to the raw, untamed power of gravity. Thanks for watching this deep dive. If you want to explore more mysteries of our solar system, hit that subscribe button. I'm Rana Asif, and I'll see you in the next video.